Hello audience. Today we will discuss about how to do the homologation for whole automotive systems. While we performing the EMC test for homologation for whole automotive systems, we found that component that works fine in its own component testing and all of a sudden it has a problem. Certain control techniques are known to produce problems. Therefore, electromagnetic interference, EMI, issues are common in spaces where large amounts of electrical devices interact with one another. Units, circuits and wires can never completely contain electricity, which can create electromagnetic compatibility, EMC, problems. Unfortunately, this means EMI can be tricky to attribute to a specific source and solve. Investigation should consist of the following test procedures. 1. Identify the source of EMI, by determining what is being affected by the EMI and how often. You can find the potential source of the issue. 2. Test the source and analyze collected data. Using specialized tools, you will need to perform tests and collect data about the potential source and emissions. The data will help you determine what kind of modification to make. 3. Modify the current system, determine and apply changes or solutions to the EM. 4. Source based on your data analysis. You may have more than one necessary fix. 5. Verify changes and confirm it. After applying a solution, you have to retest and check the source to ensure you have correctly identified and fixed the issue. Identify the source of EMI. Beginning the investigative process correctly is crucial to solving your EMI problems successfully. First, you will need to gather information about the problem. This will provide you with the background necessary to complete the rest of the process. Once you have determined what the EMI is affecting, you will need to identify the origin. Understanding how to find EMI sources and what to look for in your equipment will help you find the fault quickly and accurately. Paying attention to how frequently the issue arises is a significant factor in narrowing down options and determining the source. If it occurs sporadically, you should look into infrequently used equipment. If the problem is periodic or has a pattern, look into commonly used equipment. Test the source and analyze collected data. Once you have identified the possible source and interference recipient, you need to perform tests to verify and measure the specifics of the issue. To determine the nature of the problem, the four main possibilities are: emissions. Emissions can come from a variety of equipment and are potentially the most common reason for EMI test failure. Set limits prevent electrical interference with sensitive radio equipment, though emissions are most often too low to create an issue. Typically, only EMI testing can identify emissions. Immunity or susceptibility. Equipment can be affected by a broad variety of external sources of interference. Because there are so many possibilities, there are many corresponding tests. The most common tests include power transients, conducted and radiated RFI, ESD and even lightning. Power loads and other transients from equipment in close quarters can become issues as well. Transients do not show up in emissions testing, which is why they need to be identified separately. Susceptibility tests measure interference coming in rather than going out, as with emissions. Radiated EMI. In the case of radiated EMI, a metallic element on the electrical unit, functioning as a sort of antenna, conveys the interference. For this to be possible, the element serving as an antenna has to measure about 1/20th of the electrical unit's wavelength or another significant fraction like 1/4 or 1/2. Several pieces of a unit can serve as an antenna, including internal or external cables, slots or openings in metallic enclosures and internal circuit boards. The rule of thumb is that high frequencies are more likely to radiate, as there are few elements large enough to serve as an antenna for low frequencies. Commercial radiated emissions tests begin at about 30 MHz. Conducted EMI. In the case of conducted EMI, a cable directly conveys the interference. Since it travels without the need for radiation, it occurs in low-frequency units, typically below the 30 MHz mark. If you cannot determine whether the interference is radiated or conducted, begin testing with radiated, as it is the most common type of EMI. Depending on the type of interference you identify, several tools will aid you in locating the point where interference is radiated or conducted. By testing components of power supplies and equipment, you will be able to find the direct origin. Near-field probes, either H-field or E-field, will help point out energy sources and measure emission profiles. Sources might include DC to DC, digital to analog or analog to digital converters, processors, clock oscillators and other things that create fast-etched digital signals. Near-field probes also aid in locating non-sealed seams on shielded enclosures. Current probes measure high-frequency currents in equipment cables. It is crucial to test cables, as they are the most likely source of emissions. To record the emission profiles, you move the probe along each cable you need to check. A nearby antenna can help you analyze harmonic content and identify the issue. Compared to both the cable and internal measurements, you will be able to find the origin of the interference. After assembling all of the recorded data, look for patterns or paths that indicate why your source is interfering with other electrical units. Most of the time, it boils down to a leaky seam or poorly shielded cable. Modify the current system. Now that you have identified the source and nature of the interference problem, you can decide on the best course of action for solving the issue. You may even find that there are several sources rather than one, meaning you will need either a single fix or a combination of solutions. When deciding how to fix EMI issues, consider facility operations, affected equipment and the electromagnetic environment as well as safety, installation, overall cost, maintenance and the potential solution's performance record. You should also reach out to end users and review the options with them before settling on one. Before looking to outside solutions, you should first try to reduce or alter the path of the emission levels coming from your identified source. Some potential solutions include cable fixes. Cables are a common source for EMI issues, but the problem can stem from one or several places. For shielded cables, the complication is most likely rooted in the connector termination. This includes terminations at each link between the cable shield, connector, mating connector and bulkhead. For a temporary fix, you can close gaps with copper tape or create a shield out of aluminum foil and ground it to the housing. For filtered cables, check to make sure the assembly is circumferentially terminated to the cable connector or housing. Enclosure shield fixes. Openings and penetrations can cause problems in shielded enclosures. Openings are any seams, displays and ventilation in the unit, and penetrations include switches, fasteners and indicators. Most commonly, these are involved in ESD problems, so ESD testing can help you locate them. Closing openings with copper tape or aluminum foil works in some cases, but ventilators, displays and areas that need to stay open require conductive screens or perforated foil. Circuit board fixes. On equipment without external shields, the next option is to work with the circuit boards. Handheld radios and sniffer, H-field, E-field and high impedance scope probes all help localize the issue to identify it better. Depending on the exact problem, you will need to use filters, transient protectors, a combination of the two or, in the case of an emissions issue, onboard shields and power and signal filters. If you cannot solve the problem through general independent troubleshooting, you may need to resort to other EMI testing methods, such as purchasing and installing a more definite EMI solution. These include filtering. Using filters that target specific ranges of MHZ can help eliminate emissions. These filters will protect equipment from emitted RFI as well as keep emissions from interfering with other devices. They are available for both consumer and commercial purchase and are commonly used for conducted emissions, although they are also applicable for radiated emissions. Shielding. Radio frequency shielding is the standard for suppressing emissions. Incorporated RF shields can protect sections of circuit boards from interference or prevent emissions from affecting other equipment. Some common examples of shield types include metal films or boxes and conductive foam, but guards are available in different materials, thicknesses and shapes to suit your needs. Shields are commonly used for radiated emissions. Grounding. Grounding configurations come in many different designs to solve EMI issues. However, all grounding systems share a common purpose: to create a path of zero impedance for signals that use the system as a reference. Using an improper or inadequate configuration could be the cause of interference, so it is crucial to find the right design for your uses. Depending on the specifics of the EMI problem, using grounding techniques can reduce conducted and radiated emissions. If possible, you will want to test these solutions before you purchase and install one of them. During a test for one of these solutions, you may find that it does not work well or that the issue is different from you hypothesized. Verify the changes and confirm. After you make the repairs, you have to monitor and remeasure the emissions through testing to be sure your solution is working and continues to work. If an issue persists after applying the solution, you will need to repeat the process in the same order. Even if the solution mitigates the effects, you should completely fix the issue to ensure no further complications occur. Confirming that the solution has resolved the interference issue is crucial to the safety of your work environment, especially in military and aerospace industries. Much of this testing requires knowledge of how to operate and read finely tuned tools, so it may be appropriate to hire a testing facility or power system designer to perform tests from Croydon Services Private Limited. Using the correct troubleshooting techniques for each instrument is crucial. Therefore, we Croydon Services Private Limited will provide you end-to-end solution for EMC pre-compliance and compliance testing.